Hello, good morning, MSc second year students. So, in previous class, we have completed the radiation patterns, which contains the field radiation pattern and power radiation pattern. So, I have explained in detail of field radiation pattern and power radiation pattern. We have completed that. Today, I am going to discuss about power radiation pattern. Okay. This power radiation pattern is the see the every antenna produces some radiation. Okay, power. Every antenna radiates some power. So there will be some power loss to when the power when input power when input power is given to the antenna. Okay, there will be some power loss and there will be power radiated by the antenna. I repeat again. So if we given the input power to the antenna, uh, there will be some power loss by the antenna, and there will be some radiation power by the antenna. So this power loss can be defined as the in terms of ohmic power. Ohmic power means I square R, means ohmic means Ohm's law, which is V is equal to IR, the power which is equal to V into I. So we here V is equal to IR. So which power which is equal to I square R. So today we are going to discuss about the power gain and power efficiency. So basically the antenna is made of conductor. Okay, you know the conductor, right? What is the meaning of conductor? Means there is in conductor is a metal which consists of a free electrons. So there is a easy there is a easy pathway for electrons to pass from valence band to the conduction band. So antenna is a conductor with the finite conductivity. Okay, so there must be some ohmic loss of the conductor. I already discussed it. So this ohmic means power loss can be represented by the I square R. Then power radiated is less than the input power. So first we will give the input power to the antenna, which is equal to the power radiated plus power loss. So this power radiated, which is defined as the neta R Pn, where neta R is the radiation efficiency. Okay, this radiation efficiency of the antenna is defined as the ratio of power radiated by the antenna to the power input to the antenna. Okay, so but total power input to the antenna written as the, so I already explained that power input which is equal to the power radiated plus power loss. Hence the power efficiency can be written as, now the substitute this power in, so substitute this power in Pi in the radiation efficiency, P radiated divided by Pin. Then the radiation efficiency which is equal to power radiated by the antenna divided by the total total power input to the antenna. So power radiated and the ohmic power loss can be expressed in terms of RMS, means root mean square current. So power radiated by the antenna as well as the ohmic power loss by the antenna can be represented in terms of a RMS current, which is power radiated, which is equal to I square RMS, I RMS square R radiated. R is the resistance here. P loss means power loss, which is equal to I RM square resistance loss. Then the radiation efficiency, which is represented by the neta R. So here neta R equal to, substitute these two equations. The P radiated is equal to I square RMS radiation resistance, and the power loss, which is equal to I square RMS R loss in this expression. Okay, then when you substitute here, then IRMS square will cancel out in the numerator and denominator. Okay, so you'll get the radiation efficiency, which is defined as ratio of the radiation resistance of radiation to the total resistance of the antenna. Okay, so now the power gain. So what's the power gain of the antenna? Power gain of antenna is defined as the power radiated in a particular direction to the actual power input to the antenna. So I repeat again. The ratio, this means power gain. Power gain అనేది ఎలా డిఫైన్ చేస్తారు అంటే, is defined as the tot means power radiated in a particular direction to the actual power input to the antenna is a power gain of the antenna. Okay, GP of theta comma phi, which is equal to PD of theta comma phi. PD is the power radiated in a particular direction to the actual power input to the antenna. So the maximum power gain can be defined as maximum gain. This GP of theta comma phi is the power gain of the antenna. So now we have to define the maximum power gain of the antenna. The maximum power gain can be defined as the ratio of maximum radiation intensity to the radiation intensity due to the isotropic loss antenna is so what does it mean of isotropic antenna? So isotropic antenna is the radiation, whatever the radiation radiated by the antenna, the equally in all the direction. Whatever the radiation occurring from the antenna, that is distributed equally in all the directions. So it forms the radiation pattern formed by the isotropic antenna is the sphere. I repeat again. The radiation that is radiated by the antenna, is equally distributed in all the directions. So the radiation pattern formed by the antenna is a sphere. So its a example is a point source. Understood? So the maximum power gain is is defined as the ratio of the maximum intensity, radiation intensity, maximum radiation intensity to the radiation intensity due to the isotropic losses antenna. Okay, it is defined as GP max, which is equal to U max divided by P in by 4 pi. So, but radiation maximum radiation intensity is given by, but maximum radiation intensity is given by U max, which is equal to U max, which is equal to P radiated by 4 pi into GD max. Okay, just rearrange this expression. Just rearrange this expression. You will get U max is equal to P radiated by 4 pi into GD max. So you know that the PD means power radiated, which is equal to neta P in. So already, so power radiated which is equal to neta or Pn. Substitute here, you will get U max is U max in terms of neta or Pn 4 pi GD max. Substituting the value of U max in the expression for maximum power gain, we will get, so neta r into P in by 4 pi, so divide by 4 pi, so substitute this value U max in in this expression, in this GP max U max. GP max is equal to U max divided by P in by 4 pi. Here U max is equal to neta Pn by 4 pi GD max. So if you substitute in this expression, you will the expression will cancel out. Means P in by 4 pi, P in by 4 pi will cancel out. So at the end you will get GP max, which is equal to neta or GD max. Okay, so GP is the power gain of the antenna, GD is the power gain of the antenna in a particular direction. Maximum radiation intensity is given by this. Okay, so now I hope you understand this. So next one is directive gain, GD. So GP is the maximum gain, means maximum power gain by the antenna. So GD max is the directive gain. So now we are going to discuss about the directive gain here, or directivity D, and directivity D. So isotropic antenna, I already discussed, and isotropic antenna is the antenna means radiation radiated by the antenna, so which is distributed all over, distributed in which is equal in all the directions. Okay, so which the radiation pattern formed by this means radiation, which is a sphere which act as a point source. Okay, so omnidirection antenna means the radiation distributed only the plane లో మాత్రమే ఉంటే కనుక the radiation radiated by the antenna in equally distributed over the plane, means 2D plane. If the 2D plane అయితే కనుక it's a omnidirection antenna. Okay, it's a point radiator when the radiation equal in all the directions. the average power density. So what is the density? So so mass per unit volume which is called as a mass density. So power density means power per unit area or volume. If we take unit area, so 4 pi r square. So 4 pi r square, why we have taken the only area, not only the volume? Because it's a, we are consider the omnidirection antenna. Omnidirection means the radiation radiated by the antenna equally radiates in the equally for the 2D plane. సో 2D ప్లేన్లో ఉంటుంది కాబట్టి ఇట్స్ ఏ 4 pi r square. ఓకే, సో direct to gain is defined as GD is defined as ratio of power density to the average power radiated. So PD, so for isotropic antenna the value of direct to gain is unity. So GD of theta comma phi is equal to PD of theta comma phi P average, which is equal to PD of theta comma phi divided by PD. So P average, substitute P average here, then P average is equal to P radiated divided by 4 pi r square. So P GD of theta comma phi, which is equal to PD theta comma phi into, here in the denominator you have 4 pi r square. Okay, the take r square to the numerator, then PD theta comma phi into r square divided by P radiated by 4 pi. Here PD theta comma phi into r square is known as radiation intensity. Remember the PD of theta comma phi into r square, which is a radiation intensity, and P radiation, P means power radiation divided by 4 pi, which is called as average value of radiation intensity. So now the radiation power, the direct to power gain is defined as the radiation intensity to the average value of radiation intensity. Okay, the ratio of power density to the average power radiated. So hence GD of theta comma phi can be defined as the, so U is represented as the intensity. U of theta comma phi has like maximum radiation intensity is given by U max, like that. You can write it as U of theta comma phi by U average, which is equal to, so U average can be written as P radiated by 4 pi, so which is equal to 4 pi into U of theta comma phi into power radiated. Therefore directive gain can be defined as measure of concentration of radiated power in a particular direction. So if you want to measure the how much power is radiated in a particular direction, we have to consider the power gains, which we have to consider the directive gain. The maximum directive gain or directivity is defined as the ratio of maximum power density to the average power radiated. Okay, the directive of antenna is a dimensionless quantity. Because why it is a dimensionless quantity? Because in the numerator and denominator also power in the units of power. So D is equal to GD max, which is equal to 4 pi, so which is defined as electric field maximum square divided by power radiated, means 0 to 2 pi, integration from 0 to 2 pi, integration of 0 to pi, the electric field square sin theta d theta d phi. I hope you understand this concept.